So in this question 14, it has been given that if x is a positive quantity such that 2 to the power x is equal to 3 to the power log 2 to the base 5, then x is equal to, these are the options. So what we'll try to do is that we'll take logarithm on both sides, log on both sides, logarithm with base 5 on both sides. So if that happens, then we have x log of 2 to the base 5 will be equal to log of 2 to the base 5 into log of 3 to the base 5, which implies that if we cancel out log 2 by 5 from both sides, then we have x is equal to log 3 to the base 5. So now in option 3 we have 1 plus log 3 by 5 to the base 5. So this will be equal to 1 plus log of 3 to the base 5 minus log of 5 to the base 5, which is equal to 1. So this cancels out and we are left with log 3 to the base 5, which is equal to x. So option 3 over here is the correct option. Let's move on to the next question, which is question number 15. So this basically on averages. Here we'll be using the concept of arithmetic mean is greater than equal to geometric mean. Okay, so here it has been said that while multiplying three numbers, Ashok took one of the numbers as 73 instead of 37. So what happened? Because of that, when he took the product of all the three numbers, that product went up by 720. So now we need to find out the minimum possible value of the sum of the squares of the other two numbers. What we'll try to do, we'll take the other two numbers as x and y. So when he took 73 as the third number, so he had the product as 73xy, and he took 73 instead of 31. So 73xy minus 37xy, that was equal to 720. So that means 36xy will be equal to 720, and that means that x and y will be equal to 20. So xy is equal to 20. Now if we consider the numbers x square and y square and apply the concept of arithmetic mean is greater than equal to geometric mean. So we have x square plus y squared by 2 is greater than equal to x square y square whole to the power 1 by 2. So that implies that x square plus y square will be greater than twice of xy, and that implies that x square plus y square will be greater than equal to 2 into 20, which will be equal to 40. Okay, so the minimum possible value of the sum of the squares in this case will be 40. So 40 is the answer that we are looking for. So this is question number 15. Let's move on to the next question, which is question number 16. So question number 16, it has been said that we need to find out the number of integers x such that 0.25 is less than equal to 2 to the power x and this is less than equal to 200. And we need to find out twice x plus 2 is perfectly divisible by either 3 or 4. Now 0.25 basically means 1 by 4. So 1 by 4 means 1 by 2 to the power 2. So this means 2 to the power minus 2. And 200, as we know, 2 to the power 7 is equal to 128. And 2 to the power 8 will be 256. So that means that x will lie between minus 2 and 7. So we have x can be equal to minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6 and 7. So 2 to the power x in that case will be equal to 0.25, 0.5, then we have 1, then 2, 4, 8, 16, 32, 64 and 128. So 2 to the power x plus 2 will therefore be equal to 2.25, 2.5, 3, 4, 6, 10, 18, 34, 66 and 130. So now we'll check all of these numbers which have been given over here, whether they are divisible by either 3 or 4. 2.25 not divisible by 3 or 4. 2.5 not divisible by 3 or 4. 3 is divisible by 3. 4 is divisible by 4. 6 is divisible by 3. 10 is not divisible either by 3 or 4. 18 is divisible by 3. 34 is not divisible by 3 or 4. 66 is divisible by 3. 130 is not divisible by any of the number. So we have 5 numbers over here which are satisfying the given criteria. So the number of integers x in this case will be 5. So 5 is the answer to this particular question. Let's move to the next question, which is question number 17. The next question is a very interesting question. This is based on the concept of arithmetic progression and geometric progression. So here it has been given that x, y, z are 3 positive real numbers in geometric progression, such that x is less than y and y is less than z. Now 5x, 6y and 12z are in arithmetic progression, and in that case we need to find out the common ratio of the geometric progression, and these are the options that have been given. Okay, so now it has been given that x, y and z are in geometric progression. So if we find out the common ratio, that will be y by x will be equal to z by y, and this will be equal to k, where k must be greater than 1, since it has been said that x is less than y and y is less than z. Okay, so this is the criteria. So now it has been said that 5x, 16y and 12z are in AP. So that means that 2 into the middle term, which will be 32y, will be equal to 5x plus 12z. So now if we square this term, then this will give us 32 into 32 will be basically, if we find out 32 into 32, so we have 64 and 96. So 4, 12, 1024. So we have 1024 y square, which can be written as 1024 xz, since x, y, z are in AP. So we have y squared is equal to zx. Okay, and this will be equal to 25 x square plus 144 z square plus 120 xz. So this will give us ultimately 904 xz is equal to 25 x square plus 144 z square. Now if we divide both sides by xz, so we'll get 904 will be equal to 25 x by z plus 144 z by x. Now we have already found out. Let us find out the value of x by z. So here x will be equal to y by k and z will be equal to ky. So that implies that x by z will therefore be equal to 1 by k square. So we have 904 will be equal to 25 by k square plus 144 k square. So this ultimately gives us a quadratic equation of the format 144 k to the power 4 minus 904 k square plus 25 is equal to 0. Okay, so this gives us 144 into 25 is basically 3600. So that 3600 we can write it 900 into 4. So we'll write it down as 144 k to the power 4 minus 4k square minus 900. This is 900k square plus 25 is equal to 0. So now if we take 4k square common, then we have ultimately 36k square minus 1, and here we have minus 25, and that is equal to 0. So we have k is equal to plus minus 5 by 2 or plus minus 1 by 6. So now the thing that we need to consider is that we have considered that k is greater than 1, and also x, y, z are positive, so k has to be also positive. That is one more. So only value of k which is greater than 1 in this case is if k is equal to 5 by 2, and that is given by option 3 over here. So option 3 over here is the correct option.